Good evening, everyone. We're going to be talking tangent lines right now. So there are a couple things to remember about tangent lines. Primary among those is that if a line is tangent, so let's look at y-axis right here. So if this line is tangent, it's going to hit the circle in one place and only one place. And what we know about that is that if a line is tangent, then it is going to be perpendicular to the radius. So it's going to have the radius exactly 90 degrees. So what our goal here is do we go, okay, so is this tangent? And we look at it and we go, okay, does this form a right triangle? Well, how we're going to test that is the good old Pythagorean Theorem. So the Pythagorean Theorem works on every triangle, but every right triangle, but it only works on right triangles. So here, we know that the radius is 6.4, but the entire side of this triangle is two radiuses, or radii, it's a diameter. So that's 6.4 as well, which makes this 12.8. So we go 12.8 squared plus 9.6 squared equals 16 squared. Plug that into our calculator, and we end up with 256 equals 256. Is that true? Yes, it is. Check. Over here, same thing. We're saying, is this a right angle? Well, here, notice how they don't give us the full hypotenuse. But what they do give us is this radius right here. Well, that's 8. So if we know that, then we know that that has to be 8 as well, because the hypotenuse is going to be consistent throughout the radius is constant throughout the entire triangle. So that makes these two 13. So we go to 8 squared plus 10 squared equal 13 squared. So does 64 plus 100 equal 169? No. No, it does not. So that's how you do those. You just plug them in. So here on the next set, find the value of x. Assume that the segments that appear to be tangent are tangent. So here, this is a right angle, and we'd go x equals the square root of 9 squared plus 14 squared. Run that through a calculator. Good to go. Again, we're looking at this as a right angle. This is 7.1, so that's 7.1. So this right here is 14.2. So that is just using the Pythagorean theorem to determine, not to determine whether it was a right triangle, but knowing that it's a right triangle, figuring out what the angles are. So one of the things we also learned is that if we're looking at 12, that if two lines are tangent to a circle at the same point, not at the same point, but from the same point. Get those straight. Oh, that's not what I want to do. That is what I wanted to do. Sorry, not a straight line. Anyway, these two segments right here are going to be congruent. So just set them equal to each other. Combine like terms. Get x equals 9. Then we're going to, because it asks for wx, we'll go 7 times 9 minus 29. 7 times 9 is 63 minus 29 gives us 34. Notice if we put it in here, it should do the same thing. Or sorry, I put 7. I don't know why I put 7. It's 9. 18 plus 16 is 34. That checks. Here on, what's going on? Go away. Here on F, it says find FD. So we need this line right here. So this is a bit more complex. Again, we know that these two are the same. We know that these two are the same. So what we're going to do is when we know this is 12. We know this is a right angle. So when we find out what this is, we can then plug it back into the Pythagorean Theorem and solve for FD. FD, again, because it doesn't have that, it means the distance between F and D. So here to find the distance from E to D, you'd go 4x plus 11 equals 13x minus 16. Because again, these two are going to be equal to each other. So we set them equal, solve for x, which is going to be what? 9x equals 27, so x equals 3, so 12, 23-ish. Yeah, 23. So plug that into the Pythagorean Theorem. Blank there for a second. Sorry, guys. So again, now we're kind of doing the same thing, except we know that these two are equal, these two are equal, and these two are equal. And so once we'd use these two to find each other, we'd use these two to find each other, and then once we found what y equals and plugged it in, and we know what that O to K is, we'd then subtract that from 32 to find L to O, and then know that it's the same as M to L, add them all up. And there it is. Okay, so let's just see. I'm going to stop this one because I'm afraid of it running too long. It's only 10 minutes or 7 minutes, but I'll be right back with the other one.